definition, one-to-one. We know if it's a function, x doesn't repeat. If it's one-to-one, that's like saying the y doesn't repeat. So in one-to-one, if you have two different inputs, two different x values, they're going to give you two different answers. You don't get the same y back. So I'm just going to say y never repeats. That's an easier way to think about it. Okay, so this just says if you have two different x's, then their y values cannot be the same if it is one-to-one. So we're going to look at a few functions and decide if they are one-to-one or not. The easy ones are where I actually just list out ordered pairs or give you a table or a mapping. On A, would that be one-to-one? No. For one-to-one, I usually put 1-1. It's just shorter. And my reason would be the 38 repeats. We have two different x's that both get mapped onto the 38. B, is this one one-to-one? Yes, if you look at your y's, they are all different. So this one is one-to-one. I never have a y repeat. Okay. If I give you an equation, it's a little bit harder to tell. We'll kind of learn through practice what things make a function not one-to-one. But in general, if it's one-to-one, I told you that if you have two different x's, you have to get two different y's, right? So what we're going to do to check if an equation is one-to-one is we are going to plug in two different x's, a and b. And we're going to solve it to see if their y values are equal or not. If we solve it and we get their y values to be equal, then it would not be one-to-one, okay? Or it's kind of like proof by contradiction. We're going to plug in a and b, and we're going to set those y values equal to each other. If I solve it and I get that a has to equal b, that means the only time the y's can be the same is if you in fact plugged in the same thing twice. Then that would be one-to-one. If we get anything else, it will not be one-to-one. So for example, here is my function. To decide if this equation is one-to-one, we are going to set f of a equal to f of b. We're going to say, okay, let's assume two y values are the same. So f of a would be going to this equation and replacing your x with an a. F of b, you go to this and you replace your x with a b. So we've just said two y values are equal. Now what we're going to do is just solve this thing for a. So if I want to get my a by itself, what would we do first? Subtract our 7. So we have negative 3a equals negative 3b. Divide by negative 3, and I get a equals b. So what happened is I started out and I said, okay, these two y values are equal to each other. And when I solved it, I got that the only way those y values can be the same is if the x's are the same. That means it is one-to-one. I did. They also replaced my bulb last week, and now my replaced bulb light came on. So, all right, let's look at B. So I am going to set two y values equal to each other. So I'm going to do f of a equals f of b. So f of a is the square root of 49 minus a squared. F of b would be the square root of 49 minus b squared. How do you get rid of a square root? Squares. So when I do that, I get 49 minus a squared equals 49 minus b squared. What would I need to do now? negative a squared equals negative b squared. How do you get rid of the negative? Multiply or divide by negative 1. How do you get rid of a square? If you add square root, what else do you do? So what I get is a equals plus or minus b. So I started out assuming two y values were the same, and what I found is that could happen if the x's were the same or if they were opposites. So is this 1 to 1? No. Typically, if you have an even exponent, like a square and a fourth is 6, it is not going to be 1 to 1. Any questions on that? So that's the algebraic way. We have an equation, but sometimes we just are looking at a graph. We know if it's a function, x doesn't repeat. So in terms of the graph, that means it passes the vertical line test. 1 to 1 means y doesn't repeat. So what do you think we would look at on the graph? Horizontal test. If every horizontal line intersects the graph and at most one point, that means it's 1 to 1. So if you can draw a line anywhere, a horizontal line that hits your graph more than once, it would not be a 1 to 1 function. So to illustrate this, we're just going to graph a couple and decide if they're 1 to 1. So what does x squared look like? Parabola. Okay, can you draw a horizontal line that hits this more than once?
Yes.
Yeah, lots of them in fact. So for instance, if I drew this horizontal line, it touches the graph more than once, so this is not 1 to 1. Fails the horizontal line test. Okay, what does x cubed look like? Is that one going to be 1 to 1? Yeah, no matter where I draw my horizontal line, it only touches once, so this one is 1 to 1. It passes the horizontal line test. I feel like I'm going a little fast. Are you guys keeping up? Are we doing okay? Alright, so the next couple slides are just really some things to think about. If your function is strictly increasing or decreasing, then it's going to be 1 to 1. Strictly increasing just means it's always going up. So if I drew a graph that went up no matter what, it's never going to fail the horizontal line test. And likewise, if you have a graph that's always going down, it can't fail the horizontal line test. It's when things change direction, when they're going up and then they switch to going down. That's what creates a function that's not 1 to 1. The reason we care about 1 to 1 is for finding an inverse. So if a function is 1 to 1, then it has an inverse, which we can find by reversing the x and y values. Okay, so when we do that, we get our inverse, and we'll call that f to the negative 1. That is our symbol for inverse. So an inverse is essentially just the opposite of something. X and y flip roles. So let's say I gave you ordered pairs. Could you find the inverse of that? Yeah. So if this is my function, the inverse just takes every point and reverses x and y. So my point would be negative 27, negative 3. You don't change the signs of the numbers, you just change the order. Negative 8, negative 2. Negative 1, negative 1. 0, 0. 1, 1. 8, 2. And 27, 3. on B? What would my inverse be? Good. Any questions about that? So what we notice is if you look at the domain of the original function, what does that become in the inverse? The range. The x's and y's flip roles. So your domain and range flips. So the domain of the original is the range in the inverse, and the range of the original becomes the domain in our inverse. So that's all the next slide says. Domain of the function is the range of the inverse, and vice versa. The other thing I want to talk about is functions and their inverses are opposites of one another. So let's say, Danny, whatever number I'm going to give you, you're going to add 2 to it. Okay? You are going to subtract 2 from any number I give you. So Quentin, give me a number.
7.
7. So what's your answer?
9.
Okay? And if you have 9 and you do yours, you get, well, sorry, not from the original. Do it from his answer. So then you get 7, which is what we started with, right? Okay, give me another number. 8. If he gives 8 to you, your answer is 6. If she gives 6 to you,
8.
you get 8, which is what you started with. So a function and its inverse are opposites. So if you do both, then you get back your original answer. Okay? So in terms of compositions, if we compose a function and its inverse, we will get x back out every time. And it doesn't matter which one we do first, whether it's the function or the inverse. You're going to get what you start with if you do both operations. All right, so let's use that to decide if these functions are inverses. If I want to figure out if they're inverses, we have to do both operations and get x for an answer both times. So I'm going to do f composed with g and g composed with f. Now, I'm going to do it this way, and then we'll talk about if you had another option for how you might find that. So f composed with g means f of g of x. So g of x is x cubed. If you plug x cubed into f, f is the cube root of whatever you plugged in. What's the cube root of x cubed? X. So that one worked. It is possible for one to work and not the other, so that's why we have to look at both. So if I do g composed with f, that means g of f of x. So starting on the inside, f of x is the cube root of x. If you plug that into g, g is whatever you're putting in cubed. What happens if you cube a cube root? They cancel and you get x. So are these inverses? Yes. Both of them equal x, so they are inverses. They are the opposites of one another. Okay. Let's try a couple more. So I want to know if these two are inverses. So first step, let's do f composed with g. So that's f of g of x. G is 1 over x minus 1. If I plug that into f, f is 1 over whatever you put in minus 1. And then it had, okay, so it looked like that. You guys with me there? If I go to simplify this, what's the denominator turn into? minus 1 would just be minus 2. Does this equal x? No. If you wanted, you could get the x off the denominator. A trick we've used before is just multiplying everything by x. But even then, you just get x over 1 minus 2x. This is not x, so there's no need for me to try the other one. What can I say right now? Not inverses. If one of them doesn't work, don't bother trying the other one. You can just stop and say they're not inverses. Okay. I would like for you guys to do this one. So when I do f composed with g, that means f of g of x so if you go to plug that in, that's 3 times 1/3 x minus 4 plus 4. What's 3 times a third? 1. So I get x minus 4 plus 4, which is x. So it appears to work, but you can't assume. Go ahead and check the other way. So I'm going to go to g, replace my x with 3x plus 4. So plus 4 minus 4 cancel, so you have 1/3 times 3x, which is x. So these are inverses. Is that okay? All right. So let's talk about graphs of inverses. If you think about when we have those ordered pairs, I told you that an inverse just flips the x and the y. So what that means in terms of the graph is the function and the inverse are always going to be symmetric to the line y equals x. So I want to graph one to kind of illustrate exactly what this means. I want to graph the inverse of y equals 3x minus 2. So we're pretty good at graphing lines now. We know this is a line. Y-intercept -2. Slope of 3, so you would go up 3 over 1. So for its inverse, what you could do is take those points that you plotted. I've got 0, -2. So what point would that become on my inverse? -2, 0. You just flip the x and y. We had 1, 1, so that would still be 1, 1. So that's enough to draw it. So this is the inverse. If you drew the line y equals x in here, that has points 0, 0, -1, 1, -2, 2, 1, 1. Okay, assuming that I drew all my lines straight, can you see that if I folded my picture on that blue line, that the red and black overlap one another? That's what it means to be symmetric across the line y equals x. You drew that line and folded your graph on it, the two overlap one another.
So all you need is the, like, for 0 and -2, you wouldn't need anything else? Just use the 1, 1.
We knew 1, 1, since if you flip that, it's still 1, 1, so it would work. Since it was a line, 2 points was enough. If it was like a parabola, you would need a few more points and just reverse x and y. So doing that, the next slide I just put a graph on here. I didn't give you an equation at all. And I want you to graph the inverse of it. So we actually have to just look at our points. This is the point 1, 2. So what would the point become on the inverse? 2, 1. This is 0, 1. So that would go to 1, 0. Negative 1, 0 will go to 0, negative 1. I think my graph is a little skewed here. But this is at negative 2, negative 2, so that would still be at negative 2, negative 2. So we get that graph. Any questions? So the last piece of this is to actually find an inverse. That's where we're going to end today. To find the inverse, first thing, if it's written in function notation, f of x, you need to change your f of x to a y. Then, when you find an inverse, x and y flip roles, so we're going to switch our x and y. Solve the new equation for y, and at the end, go back to function notation. Instead of y, we'll write f to the negative 1, f inverse of x. So we're just going to try a few of these to finish. Find this inverse. So first step, instead of f of x, you write y. What's the next step? Interchange x and y. So every y becomes an x, every x becomes a y. Okay, next step. Okay, so we subtract our 3. Divide by 2. Okay, now instead of y, we write f inverse of x. So there's my inverse. Questions there? Let's do another. Do you guys remember doing this in Algebra 2? So step 1, instead of f of x, we write y. Switch x and y. Since we have multiple x's here, both of those are going to become y's. Okay, what do you think we need to do next? Multiply by our denominator. So if I were to distribute, we get xy minus x equals 2y plus 1. I have to solve for y. That means I need all of the y's together. If I look at this, I have a y here and here. So I need both of those terms on one side and all the other terms on the other side. So I am going to subtract over this 2y. And I'm going to add over this x. So we get xy minus 2y equals 1 plus x. What now? have a y, but they're not like terms. I can't subtract them. We need to divide. In order to divide, you need two things being multiplied. So what do I have to do before I divide anything? Factor out y. If we take out y, we're left with x minus 2. So then you can divide by that whole thing. So y is 1 plus x over x minus 2. Always make sure your final answer can't have any y's over here. Okay. Final piece, instead of y, we write f inverse of x. This one asked for domain and range. So we need to do domain and range for both functions. So I'm going to put d with a little f to mean domain of f, and I'm going to do the inverse. For the domain of the function, let's look at our original. It was a fraction. If you have a fraction, what do you know? The bottom can't be 0. What would make the bottom 0? 1. So my x can't be 1. So I'm going to write that as negative infinity to 1 union 1 to infinity. Now, you know that the x's in the original function become the y's in the inverse. So that means the domain of the function is the range of the inverse. I'm just going to copy that down. These will always be the same. Okay, it's a little bit harder to look at an equation and find a range, so let's drop down to the inverse for a minute. Can you tell me the domain of this inverse? It can't be 2, so I'm going to write negative infinity to 2 union 2 to infinity. And you know the domain of the inverse is the same as the range of the original function because it just flipped x's and y's. So if I ask for domains and ranges, all you really need to do is find the domain of both the function and the inverse. And then those are the range of the opposite function. We will. We're not. We'll do that.
It's everything except
Yes.
for that.
Yes, you could think of it. It's really just your vertical asymptote. And your range is really just where you have your horizontal asymptote. Okay. Questions there? Why don't you guys do this one? F of x with y. Switch x and y. Solve for y, so add your 1. Divide by 2. How do you get rid of a cube? Do you have to have a plus or minus for that? Only for even roots. So it's the cube root of x plus 1 over 2. Change y to f inverse of x. I didn't ask for domain and range, but I could. What's the domain of the original? Negative infinity, positive infinity. The final, 2 is never 0. You can do the cube root of both positives and negatives, so the domain of the original is also negative infinity to infinity. So all 4 parts would be negative infinity to positive infinity here. Alright, last one. X squared, we already saw an example where it failed the horizontal line test, so you can't find its inverse. But I put a restriction here that x had to be greater than or equal to 0. That meant we're only looking at the positive half of this graph. So if I were going to find the inverse, Your f of x is your y. If you switch x and y, what would you have to do to get rid of your square? And when you add square root, you do plus or minus. However, if x is positive, can you have the negative part? No. So because I restricted, because of this restriction that we were only looking at positives, when I do work my inverse, I'm going to drop the negative. So my inverse is the square root of x. I think I want to do one more fraction problem, and then that'll really be the end. I want to do one more if we have to do domains and ranges. So let's say f of x is equal to x over x minus 2. Let's do the inverse domain and range. So what's my first step? Okay. Next step?
Switch your x.
Okay, we are going to solve for y here. So we have to get rid of the fraction, so I'm going to multiply by y minus 2 on top and bottom. So I get xy minus 2x equals y. Now what do we do?
Go ahead and next.
But I'm trying to solve for y. We need all of our y's on one side. So if you want to subtract this y over, you could do that, but then I need to move my 2x. So we're trying to group all of our y's together. So I get xy minus y equals 2x. Now what do I need to pull out? Y. So then you can divide. Change your y to f inverse. I've got my final answer. Let's do the domain and range. While I'm looking at the inverse, what's the domain of the inverse?
Negative and negative.
So what other one is that going to be equal to?
The range.
So I can write that twice. Okay. If we look at the original, what's your domain? And that would be the same as the range and the inverse. Any questions for me, guys?
If we just write like d of f and